Alright, geometry. So, here we go, starting our standard 10 with similarity of polygons. Okay, so let's look at what it takes to earn proficiency levels here. Okay, so level 1, you're at the beginning level. If you can determine the length or measure of missing sides and angles given a similarity statement in separate polygons, or if you can solve for missing measurements using the triangle proportionality theorem. Okay, you advance to a level 2 if you can determine the length of a missing side given a similarity statement in separate polygons, and so if you can do both of the level 1s. Okay, you reach the level 2. Level 3 proficiency can be earned by earning a level 2 and also determine missing values of overlapping triangles when given a similarity statement and diagram, and you can also determine whether lines are parallel using the converse of the triangle proportionality theorem. Okay, and then you can progress through to the level 4 if you are proficient, and you can also write a similarity statement. You can identify the scale factor, and you can use the correct similarity criteria. Okay, so again, I know that this might all be foreign since we haven't started this yet, but we will continue to look back at this to check your level of proficiency. Okay, so today we have in class 42. Okay. And we're going to start by looking at polygon similarity. Okay, polygons are similar. So first of all, similar notation, similarity is just one little squiggly line there. Okay, and we can determine that if polygons are similar if and only if all pairs of corresponding sides are proportional. So not congruent, but proportional. And all pairs of corresponding angles are congruent. Okay, so the angles have to be the same measurements, but the sides have to be proportional. Okay, so using similarity statements. So if triangle ABC, so let's get a label on these triangles here. I think that should have been, so we're going to call this triangle ABC and DEF. Okay, so if the two triangles are similar, okay, then corresponding angle A is congruent to angle D. So corresponding angles are congruent. Okay, so if angle A is congruent to angle D, what's another angle that we know is congruent? Would be angle B would be congruent to angle angle B congruent to angle E. Okay, and the last one would be that angle C is congruent to angle F. Okay, so they would be the same measurements. Okay, but sides are, what did we say? The sides are proportional. So not equal, but proportional. Okay, proportions we write as fractions. So side DE is proportional to AB. Okay, side DF. Okay, note where they are, DE and AB. So EF would be proportional to ABC. Okay, so the order you write the similar triangles matters, right? Okay. And the last one would be DF is proportional to AC. Okay, all of those would be proportional. Okay, so in the apply it says using the definition of similar polygons above, complete each of the following problems. Okay, so if you're given triangle AFG is similar to triangle DRH, angle H would be congruent to angle G, right? See how they're both last. DR are the first two, the first segment, over AF, okay, would be equal to DH, so the first and last points on that segment, DH, would be over AG. Okay, angle D would be congruent to angle A, good. Okay, so then RH is on the bottom here. And what is the side that would be proportional to RH from the first triangle? Would be FG. And that would be equal to AG over DH. And are there more we could give? Yes, there's more that we could give here, right? Okay. All right, so use each similarity statement to solve the missing measurements. Okay, so ABC is similar to EDC. So for example, angle B would be congruent to angle D at 81 degrees. Okay, sorry, congruent angles. Okay, so we are asked to find all of the missing parts, X, Y, and the measure of angle E. And the measure of angle E would be congruent. I'm just doing the angle first because we're most familiar with that. Angle E would be congruent to angle A. We don't have angle A given to us, but what can we do to get that? We have the other two parts of the triangle, right? So subtract those from 180 and we get angle A is 56 degrees. So the measure of angle E is equal to 56 degrees. And I need to find X and Y yet. Okay, so to find X is side ED. So what side is proportional to ED would be AB. Okay, so 8 over X. So we did ED was over AB. And that would be equal to, now we need another two sides, a side on each triangle that's proportional where we know them both. Okay, so if I look here, I know CE. So I want to know, do I know AC? I don't. I know CD. Do I know BC? And I do. So make sure that ED is what we used for our top, or I'm sorry, I wrote that backwards. We did AB over ED. Wrote that backwards, I apologize. AB over ED. And we said CD and BC are the other two we're going to use. So since you got to keep the triangles on the top or on the bottom, in the numerator or denominator. So BC would be over CD. BC over CD or DC. Okay, so 8 over X is equal to 5 over 2. And once you have the proportion written, you remember we cross multiply. So 5X equals 16. Divide by 5, and we get X equals 3.2. And now find Y, doing the same thing. So we can still use our 5 over 2, since those are two we know. Okay, and I need to know Y, which is now on the ABC triangle. So Y is going to be over, which on the smaller triangle is proportional to AC, would be EC. So that would be over 3. Okay, so cross multiply and I get 2Y equals 15. divide by 2, and I get y equals 7.5. And you're done. You found all the missing parts. Okay, on the next one, we're asked to find x and y when triangle NKP is similar to NKL. So again, let's start by finding two sides that are proportional. Should have done that first on the last one. It's helpful, right? So PK is similar to KL, is proportional to KL. Okay, with PK over KL, I have 5 over 4. Okay, so since I need, we can use X or Y, whichever one you want to find first. NL is proportional to MP. Okay, so the 5 came from PK's triangle. So MP needs to go on top with 6.25 over NL, which is X. So 5x equals 25. When I cross multiply, divide by 5, and I get x equals 5. Okay, if it helps, you can write all your proportional statements first. PK over KL is congruent, so we use PK, we can say MK over NK equal to MP over NL. If you want to start by writing those out, that might be helpful. So PK over KL we knew as 5 over 4. Okay, again, you need to, since you're trying to find something you don't know. So Y is MK, and that goes over NK, which is 3. So when I cross multiply, I get 4y equals 15. Divide by 4, and I get y is 3.75. Okay. 2 more for this lesson here. Okay. Using each similarity statement to solve for the missing measurements. So given ABC is similar to triangle ADE, find x, y, and the measure of angle ABC. Okay, so to start with, how about we write our proportional statements? So AB over AD equals BC over DE, which is also equal to AC over AE. Okay, so we can start with that. So AB over AD would give us 2 over 2 plus x. Right, the total length of AD would be 2 plus x equal to BC over DE, which is equal to AC over AE. Again, the total length there, you have to add those together. Okay, so we can't obviously use these all at once, but now that we've got them right now, we know that's a y. Sorry, kind of ran together. We can use 1 over 4 equal to y over 6 to find y. So I get 4y equals 6, divide by 4, and I get y equals 1.5. Okay, and I can use 1 over 4 equal to 2 over 2 plus x to get 8 equal to 2 plus x when I cross multiply. So subtract my 2 and I get x is 6. Only thing left to do is to find the measure of angle ABC, so I need this one here. Okay, so what can I do to find the measure? Okay, first of all, I know 95, 38, and then I can find D. by taking 180 minus 95 minus 38, and I get 47 degrees for angle D. And I found that because angle B and angle D are congruent. So the measure of angle ABC is equal to 47 degrees. So again, I found all three parts that they asked me to find. Okay, and the last one. Let's start by writing our proportionals. I think it'll end up saving you a lot of time. RS over WX is equal to ST over XT, which will be equal to RS over WT. Okay, so when I fill these in, RS is X over WX is 15, equal to ST, which is 15, over XT, which is 12. There's my one I'm going to be able to use because I know both. Oops, I did this twice. RS over WX, ST over XT, and RT. Sorry, that was supposed to be a T. You guys probably already caught that. Over WT. So RT is 20. WT is my Y. So again, you're never going to use all three at once, but that way it's pretty much all set up for you. So to find X, I can do X over 15. And if you prefer, you can reduce this, right? These can divide by 3 to give you 5 over 4. So I can set that equal to 5 over 4, so it's already reduced. Do you have to? No. Divide by 4, and I get X is 18.75. Then to find Y, I can use my 5 over 4 equal to 20 over Y. So cross multiplying, I get 5Y equals 80. Divide by 5, and I get Y is 16. Okay, so that 5 over 4 is what we're going to call our scale factor. Okay, so it's going to be our scale factor that we'll get more into later. Okay, and that finishes our in-class 42 on Polygon similarity for today. So you should now be able to go ahead and complete that homework.